Hello, my name's Jason Weber. I am the Vice President of Product with Veracity Industrial Networks. With me is Rhett Smith, who is the Product Manager for the Industrial Switch line at Schweitzer Engineering Labs. We're going to talk a little bit today about some of the switches that Veracity works with and we run into at customer sites and what makes them special. So Rhett, why don't you introduce yourself and a little bit about Schweitzer?
Yeah, thanks, Jason, and thanks for having me. My name's Rhett Smith. I've been with SEL a little over 17 years now. I'm a principal engineer in research and development and the communications department. I manage the portfolio for the cybersecurity and the networking technology. SEL, our main technology really focuses on the energy sector. We build protection, automation, and communication solutions for the electric power industry, the oil and gas industry, and a lot of the other critical infrastructure markets. When I talk about critical infrastructure, it's really those important systems that society depends on, like the power system, the water system, the transportation system. So that's really the kind of high reliability and safety that our systems are after. So thanks.
Oh, sure. No, it's great to have you on here and talk about it a little bit. Since we're mostly in the manufacturing space and those sort of networks, the OT space, people may not be quite as familiar with Schweitzer Engineering Labs or SEL or the blue boxes, as sometimes you're known as. But one of the things that we've got a pretty tight partnership between the two companies, and you guys have had support for software-defined networking and OpenFlow for quite a while, which is the types of switches that we need to use within there. And so want to talk to you a little bit and give you a little bit of a chance to talk about your switches and what makes them special. I happen to have one on my desk right here, the famous SEL Blue here. But tell me about where your switches are made, how they're made, and we've talked a little bit about critical infrastructure switches. And can you shed a little light on that, Rhett?
Sure. Yeah, it's an interesting story because when we first went out to build the goal of ours was to build a protection class Ethernet network. And what that really meant was a network that could be up and keep the signal integrity that communication assisted protection needed. And when I talk about protection, that's the power system protection. So if you have a fault on transmission or distribution lines, we want to, shut that power off, right? We want to protect both human life and the physical system itself from, those short currents. So when we evaluated that, we attempted to use the traditional networking technology, the rapid spanning tree, those kind of technology for many years. And those days were awful fun in research and development because we kept failing. Going back to our management saying, nope, still didn't make it, still didn't meet the requirements that we laid out for ourselves. And I remember that meeting after one of those difficult, updates to realize we didn't quite make the benchmarks we were after. And one of the engineers on the team just softly said, have you ever heard of a protocol called OpenFlow? And from that point forward, the rest of it, just all the pieces fell into place after that. Because what we ended up finding out is when we transitioned to OpenFlow, the data plane and control plane became programmable. And the benefits of having that programmability put the power back into the system owner's hands to be able to design the perfect network for their critical infrastructure system. So now they have the flexibility to determine what devices they want on their network, what conversations each of those devices are allowed to have, and who they're allowed to have those conversations with. So it started with this deny by default structure, and then they're able to provision the circuits that they wanted to from that point forward. And it really was this shift in mindset of what's possible. Now you have north-south control as well as east-west control on your network. So it wasn't, it was still standing on the shoulders of the great Ethernet interoperability that we always, depend on. So all of the hosts continue to communicate like they always have. Now we were able to stand on this interoperability, as you know, between Veracity and SEL, can communicate with the control plane. So the OpenFlow is an industry open standard that has been proven out for many, many years in the IT side for data centers. And we have now brought it over into the OT space and shown the value and benefits of OpenFlow, not only in this kind of programmability, but the interoperability that brings, where they can choose best-in-class solutions for switches, controllers, or value-add applications. Because now we have this software technology stack that is interoperable at the API, or application programming interface, and we have this control plane between the controllers and the switches that are interoperable with the OpenFlow standard, that give us great flexibility for control, resulting in predictable, reliable, consistent, and deterministic networking for critical infrastructure.
Absolutely. And much easier to manage than a traditional network. That's one of the things that,
right.
I mean, most of our customers don't have money to give us to make things easier, but they definitely want to lock things down. They want to make it so that they can manage these networks and keep them secure.